All right, we're going to walk through a little numerical practice problem on perfect competition. This comes from the material in Chapter 8 of your Intro Econ OpenStax textbook. The assumption here is that you've gone over the theory, the definition, the concepts of profit maximization in the short run and the long run in perfect competition, and this is just a little numerical scenario to work through. So imagine this is an exam question or homework question, something along those lines, and you're given the following information. So we have a table representing obviously a very hypothetical situation. Say, for example, an automobile manufacturer in a competitive industry. We know that there's only a relatively small number of firms producing cars, so it doesn't fit that definition of perfect competition. But just as an example, and just note that the numbers on the table are in thousands of dollars. That's not going to affect any of our uh, calculations here, but just to make it more realistic. Uh, and likewise, the units of output here, the little qi, the quantity for our one single firm, are in thousands of units. And we're given the total cost, the average total cost, and the marginal cost. And of course, the behavior of those costs are dictated largely by diminishing marginal returns to labor. So you should be able to explain that. That's based on the Chapter 7 material. But what we want to be able to do is take this information, combine it with information on the revenue side, uh, the demand side, basically for the firm, find the profit maximizing level of output and show it all in a graph, and then talk about the implications for the long run behavior of this industry. So with this as the starting point, again, if this was an exam question, for example, you might be asked to sketch out what you see on that table. So looking at the marginal cost and the average total cost in particular, we see that the marginal cost has that typical little check shape to it. So it comes down as we're experiencing increasing returns to labor. And then once we hit those constraints of fixed capital in the short run, additional labor is giving us less additional output. So our additional units are costing more and more. So we're going to come down, hit that inflection point where diminishing returns begins at a quantity of 2 and the level of marginal cost of 4. And then it's going to be increasing, in this case, in a linear fashion after that. So it'll look like this. So that minimum point, bottom of that check, there is at the second unit of output and the value of marginal cost of 4. And again, that's at that minimum point that we see. And then we'd want to be able to add our average total cost on that same set of axes there. And remember how that relates to marginal cost. Average total cost decreases, hits its minimum point where it intersects marginal, and then starts to come up as those additional units are raising the average. So the shape of the curve is going to look like this. And then we want to do our best, right, to figure out where that intersection point is. So in this little portion of the table up here, we take out that intersection point, and we notice that when output was 6, the average was above the marginal. So we're somewhere here, average above the marginal, and output 7, they flip position. So the marginal at 14 is above the average at 1286. So that's going to be somewhere over here. So we can not exactly locate where that minimum is. It occurs somewhere in that range between 6 and 7. And this is a pretty good picture of what that cost structure in dollars per unit looks like for our hypothetical firm. But of course, in order to solve the profit maximization problem, we need to know the other side of the profit equation, right? So this is the cost, the money going out. We need to know about the money coming in. So imagine we turn to the next page on the exam and we're given this information, that we have a market equilibrium price equal to 10. So again, in our case, $10,000 per automobile. What does that tell us about the firm's revenue structure? Well, remember, this is going to be really easy when we know that this is a perfectly competitive firm. one of many firms selling an identical product that is going to be a price-taking firm. So once that price is set in the market, each firm is going to be charging that same value at every quantity. So the graph on the left here is the entire market equilibrium. And here we're told that that equilibrium price is set at 10. And then the graph in the middle is our individual firm. So we go from big Q, total output in the market, to little qi, output from just our single firm. And it's going to be at that price of 10 at every quantity. So that perfectly elastic demand set at the equilibrium price, and that's our marginal revenue as well, which gives us that nice, easy structure for the total revenue. It's going to be a linear function of quantity. Every time we sell one more unit, we're going to earn the market price in return, in this case, the $10 or the $10,000 in our example. Okay. So with that, we can now fill out the next two columns on the table, which are going to be total revenue at every level of output. And what we really want to find out is the level of profit at every level of output. So to get our total revenue, it's just price times quantity. So 10 times Q all the way down. So we produce zero output, we earn zero revenue. One unit at 10 gives us 10, two units at 10 gives us 20, so on and so on and so on. So every row, we're adding one unit of output. So we're adding another $10 in revenue based on what we were told was that equilibrium price. And now the next column, our profit is just going to be total revenue minus total cost all the way down. So when we produce nothing, we earn zero revenue, but we have to pay our fixed costs. So we still have that cost of 30. So 0 minus 30, negative 30. Produce one unit, earn 10, but our costs have gone up to 36. 10 minus 36, negative 26. 20 minus 40, at output of 2, negative 20, so on down the line. Okay. And we notice a couple things about those numbers in the profit column. The first thing we notice is that they're all negative, right? So even if this firm does the absolute best it can, which is what we'll assume that it will follow that rule of profit maximization, its cost structure combined with its revenue structure is such that it's always going to be losing money. It's always going to have negative economic profit. But we do notice that the losses come down and they are minimized here at negative 14 at either units 4 or 5, and then start to rise again after that. But all we can do is best we can. So again, if this was an exam question, you would be asked, where is the profit maximizing, the optimal level of output? And you will always simply follow the rule. We set marginal revenue equal to marginal cost. And in the case of a competitive firm, marginal revenue is the price. So we know that the price is 10. So we just ask ourselves, well, where is marginal cost also 10? It's here at quantity 5, right? So that's going to be our so-called QI star, the best choice, the optimal level of output. I mean, the logic there is you keep producing that marginal unit, one more unit, as long as price is at least as great as marginal cost. But once they hit an equality, they equal each other. Producing one more is going to have a higher cost than the additional revenue, and that's going to be a bad idea. So the best we're going to be able to do is this profit of negative 14 following that rule of profit maximization, in this case, loss minimization. So the next step, you turn the page on the exam, and it's going to ask you to show on that same diagram that includes marginal cost and average total cost, show where we can find our QI star and show where we can indicate the level of profit. So combining that marginal revenue, which is our price, which is our demand, with marginal cost and average total cost, well, as we saw, profit is negative everywhere, including at our optimal point. So the marginal revenue, the price is always going to be below our average total cost. So setting our price here at 10, start with finding the optimal quantity. So when marginal cost equals 10, that's where we found our QI star, that at the level of output of 5. And then from there, we go straight up to the average total cost. And on the table, we see that that was 12.8, right? If we just go back real quick, sorry, we're looking at this number here, right? So when we're producing 5 units, we're earning $10 per unit, but it's costing us 12.8 to produce per unit on average. And that's what's driving, of course, our losses. So step number one, find the intersection between price and marginal cost, giving us the optimal quantity, then find the level of average total cost. And now we can show that profit calculation. It's going to be our price minus average total cost, so our loss per unit in this case, times the number of units. So it's going to be this area bounded by our profit per unit, that vertical distance between price and average total cost for all the units produced, so times the length, and that gives us our profit of negative 14. So we're losing $2.8 per unit, and we're producing 5 units, so a total loss of negative 14. So you want to show that little rectangular area, again, bounded by price, average total cost, and then quantity lengthwise. Okay, so far we are acing this question. But there's one more big one when you flip the page. Given that our representative firm is losing money, what's going to happen to this industry in the long run, right? So what are the long run dynamics that would play out here? And the big thing is we have to remember that those profit levels are economic profit, right? So there's the embedded comparison to your next best alternative. So if you're losing money in the sense that you have negative economic profit, it means you could be doing better somewhere else. So once that is concluded, once the long run comes around, remember what that means. Now your contracts are expiring. You can move to a different production facility. You can change what you're doing. Right? In other words, you can shut down and try something else, which is definitely the incentive here. So with negative profit in the long run, firms start to leave. Right? They start to exit the industry. And now we just have to remember, well, wait a minute. The market supply curve is a function of the number of firms producing the product. So as firms start to exit the industry, that market supply is going to start to drift to the left. And now you're back in, week 2 of the semester. When a supply curve shifts to the left, that creates a shortage at the initial price, and that's going to start to put upward pressure on prices. So the firms that haven't left yet can now charge a higher price, and that gap between cost per unit and revenue per unit is going to start to shrink. And that process is going to continue until enough firms leave such that prices rise to meet that average total cost. Now the firms that have stuck it out, in other words, their contracts haven't expired yet, they maybe wanted to leave, but they didn't, they are now breaking even again. And once that price reaches the average total cost and profit reaches zero, well, now that means you don't have any incentive to leave. A zero economic profit means you're doing just as well in your current activity as you could somewhere else. So that's where the market's going to stay. So you have to be able to tell that story, kind of those little steps, and show it on a diagram. That's the fun part, right? So remember how we started this off was that price of $10 came from the market equilibrium, intersection of market supply and market demand, and that gave us our individual firm losing money, right? And also keep in mind that this graph here showing the marginal cost and average total cost is one of, hundreds of firms, all supposedly identical. This is just our representative firm. So now, in the long run, that supply curve starts to shift to the left, up and to the left as firms start to leave. That pushes price up, and eventually, think of this as it's not going to happen instantaneously, but it's a process. That price starts to rise, starts to rise, starts to rise as our supply drifts off to the left, and it's going to stop moving once we hit that zero profit point, once it reaches the average total cost. So that's going to be the firm's new perfectly elastic demand at that higher price. And we can approximate here, if you go back and look at the table, the average total cost bottoms out at about a value of 12.6. But as long as you can show it on the graph and kind of approximate it, that's where the market and the firm are going to end up. And that's where they'll stay until something else happens. There's a change in wages or costs of inputs, or the demand curve for their product shifts. Then that's going to push us into a non-zero profit short run equilibrium and out of long run equilibrium. But this is our long run equilibrium point. No incentive to enter, no incentive to exit. All firms in the industry are making zero economic profit. And you should be able to tell that entire story from that beginning table. Once you're given the price, solve everything out, show it on the diagrams, and then show the evolution here. So hopefully that was helpful, and we will see you next time. Thanks.